So, particles moving in a circular path. So far we've dealt with linear and angular velocity and radii, but there's a reason an object moves in a circular path. But what we need to do first is we need to look at the fact that the velocity in that diagram is changing directions all the time. It's always a tangent to the circle, and if the velocity keeps changing direction, it means the particle is accelerating. If the particle is accelerating, there must be a force causing the acceleration, and this force we call the centripetal force. It's always perpendicular to the velocity, so it's always directed towards the center like so. So as the object goes around, the centripetal force is directed towards the center of the circular motion, and that causes the particle to accelerate, which causes the velocity to change. Now there's a formula for it as well. The centripetal force is given by the mass by the linear velocity squared over r. Now pause the video and write down the other variety of that formula, because the other variety of that formula from the log tables is the only formula in the syllabus. So mv squared over r, while you will use it more often than not in textbook calculations, is actually not in the syllabus. So you're not required to know it, you're required to know the other one. Now, the relationship between the two formulas is very straightforward. You use V is equal to RW to go between the two, and I'll show you that at another time. What's important here is that the centripetal force is determined by the mass of the object moving in a circular path, by the speed of the object moving in a circular path, and how far that object is away from the center of rotation. Okay, in terms of relationships, the centripetal force is dictated by the mass of the object. So if the object is a greater mass, the centripetal force will be larger. If the object has a larger linear velocity, the centripetal force will be larger. And if the radius is larger, the centripetal force decreases. Now, the other formula as well, I'd like to know what is the relationship between the centripetal force and each of the quantities in that formula as well. So you'll have written it down, but I'd like you to be able to describe what the relationship is also. Now I'm going to keep going. Centripetal acceleration. So if there's a force, the force causes an acceleration, and the acceleration is usually in the same direction as the force. In which case, I can say F is equal to ma. The m's will cancel both sides, and instead of having F is equal to mv squared over r, just get rid of the m's on both sides. A is equal to v squared over r. Again, can you give me the other variety of that formula? And can you also tell me what is the relationship between the acceleration and each of the quantities on the right-hand side? Now for you guys, will you do 1 to 7 in activity 12.3?